Good morning. Welcome to the camp buff. Can everyone hear me okay?
Hear you loud and clear.
Very good.
Very good. Okay. So this is the computing aware networking buff. Um, Linda and me are the co-chairs for today. We'll get started right now. First, note well. Please note that you agree to follow the IETF processes and policies, including IPR policies, and also please be courteous to your colleagues here. We'll skip the details here. Some meeting tips. If you are here in person, please join the on-site session of Meet Echo. If you are remote, make sure your audio and video are off unless you are presenting. We'll skip the resources for this. So this path, what it is about, the computing aware networking aims at the computing and networking resource optimization by steering traffic to appropriate computing resources, considering not only the routing metric, but also computing resource metric and service affiliations. We have a mailing list, Dinecast at ietf.org. We already have the note takers. Thank to David and Zheng Hao. Much appreciated. So the purpose of this buff is to increase the awareness and participation in computing aware networking so that efforts can be organized coherently at this stage of researching to early engineering transition. We will have a few words from our AD, John, later. During this Bob, we want to have these questions to have in mind so that when we come to the end of the discussion meeting in the discussion phase, you will have some sort of opinion on, for example, are the use cases important? Are there already existing and sufficient solutions? Do you think the proposed solution will be useful or harmful in any way? Would it be IETF work? For example, if yes, is it in routing area and which working group or somewhere else? Also, is there energy to continue the work? So we will, for the agenda, we'll start with the problem statements and use cases and requirements. And then we're talking about two potential solutions. One is load balancer based. The other one is this dynamic anycast architecture. We'll then come to the open discussion for 15 minutes. And then finally, we return to those questions with chairs and ADs to facilitate the discussion there. I'm sorry, it's hard for. Oh, okay. I'll speak louder and closer. Okay. So I think for now we'll just turn to our AD, John Scudder.
Thanks, Jeffrey. Good day, everybody. Thanks for being here. Yeah, I don't have a ton to say beyond what Jeffrey already said to introduce the bot. So thanks to Jeffrey and Linda, first of all, for agreeing to share, and I think they've done a great job of pulling the BOF together. Yeah, so when we were approving the BOF, there was some sort of it seemed like the history and discussion was largely around, um, is there, you know, well, actually, basically the questions that Jeffrey already projected, which is this new work, what group should it land in, and is there energy to tackle it? So that's what I hope the participants will stick with. In particular, in the IETF, we have a love of immediately diving into debating about the details of solutions, and I hope we won't do that today. Um, although debating about solutions is, of course, very much fun. Um, so yeah, please do keep in your minds as we're going through the BOF today the questions that Jeffrey just projected, and I hope we're going to come away with this with some idea of what our next steps are. Thank you very much, and let's go.
I just want to add a few words. For people who speak or answer questions, please check the notes, make sure your questions and answers are captured correctly, and also your names.
Okay, thank you. So now we will get started. The first presentation is updates on the related industry and standard organizations.
So, sorry, Jeffrey, let me interrupt for just one moment with a question for the chairs. I see there's a hand raised in the queue, and I just maybe you can say a few words about how you want to manage the queue and Q&A during talks and so on.
So I hope that the questions during the presentation only for clarification. Like, say, for example, you can ask, hey, I heard you said this, what do you mean? And for the debate, let's wait to the open discussion about alternative solutions and different ways of achieving things. So we see there's a Georgia has a question.
Yes, my name is George Karagianis from Hawaii. I would like to mention that we had some side meetings that are somehow related to, to the content of this BOF. And I would like to, so we had, I think, one on during the IETF 110 and another one on the IETF 109. So the name of the side meeting was Dynamic Anycast, so Dynecast. And we had, during that side meeting, the last one, we had actually also 3 questions whether the use cases that were provided there were well useful. So there were some 40% from 60 people that were in the side meeting said yes. Then from there was also a question on whether the content of the Dynecast was related to the surrounding area. So there was, I think, some 47% that from the people in the side meeting that said yes. And then the last one, if there was an interest to work on a BOF, and there were some 50, I think, percent of the people in the side meeting. Just wanted to make a connection to what happened previously. Thanks.
Thank you.
Thanks.
Hello, everyone. This is Luis Contreras from Telefonica. I will present a refresh on 2 initiatives that are being moved forward in formal standardization bodies in ETSI and ITUT. And if time permits, I will also comment on some other initiatives that could somehow complement the overall picture. So I will first talk about the initiative in ETSI MEC. The initial idea of MEC, you saw in the title, when MEC was conceived, was the idea of exploiting, let's say, edge computing capabilities distributed across the network, basically thinking on mobile access, right? This is why the initial acronym of MEC was standard for mobile edge computing. But along the time the work is being done in ETSI, The purpose is somehow generic, so dealing now or changing, let's say, the scope to multi-access edge computing, in the sense of also considering fixed accesses, fiber access, and so on and so forth. So what was the original motivation of ETSIMEC? The idea was to put into value some ideas that could, or some purposes that could be achievable through deploying edge computing capabilities in the networks. First, getting contextual information. So information that could be valuable for applications and services to exploit, let's say, to provide better mechanisms for delivering services. Contextual information such as where the user is located, what kind of access technology is using, even which kind of terminal, and so on and so far, in order to improve the delivery of the service. Also to have advantage of proximity. With proximity, we can enhance several parameters, several service level objectives, such as latency or throughput, and so. And finally, having a number of facilities able to host applications in the border. So this was more or less the main motivations of the work that started in ETSI. Along the time, ETSI-MEC has been working also in integrating this solution with other solutions like ETSI NFV, 3GPP, Broadband Forum, and so on and so forth. So trying to get, let's say, a consistent approach to deploying these edge computing facilities across the network. So what you can see there are the number of participants in ETSI-MEC, and so all the specs are available, and you can check with more detail. So next, please. Well, the idea of MEC, somehow MEC changes a little bit the story on how the applications could be developed. So the idea is to transition from the original client-server approach to something that involves another additional party, right? So we have a client, the edge part, and the remote part at the time of delivering or creating the applications. This could have some implications in terms of how to handle the traffic, because I mean, there could be different procedures, different processes for steering the traffic across the different parties into the network. So key issues to understand how influence MEC on the routing and so are somehow listed in the slide. So how to discover the edge by the users, how the users connect to the different edges. So what is the determination of anchoring one user in one edge or another, or redirecting one user to an edge or another. What could be the capabilities of the different edges in terms of service to be provided to the user, how to guarantee QoS, and what happens when the user is moving. No? This is probably, well, this is immediately take or heads to the idea of mobile, but also we can consider seasonal periods where maybe a fixed user is moving from different locations, and probably could be of interest to take with him or her the contents but along he is located in different places. Next, please. So typically in ETSI-MEC, the developments take periods of 3 years. So in the case of ETSI-MEC, we are now in the 3rd year. In the second and the third, there have been interesting developments that are somehow highlighted the integration with 5G networks, so how to make MEC coexisting with what is being developed in 3GPP. We will comment a little bit later on this. And now in the third period, we are, ETSI-MEC is working in some other capabilities. Could be the deployment of MEC facilities in enterprise environments. So this is linked with the idea of the vertical industries and so how to leverage on those facilities that could be in different administrative domains, the private one and the public one. And also, it's not highlighted here, but also MEC is working on federation. So how to integrate resources from different providers. And this could also have implications in terms of routing the traffic, because we are moving from the single domain environment to the multi-administrative domain environment with could have some implications on that. So next, please. So here in this picture, you can see how MEC is being proposed to be integrated with 3GPP network, with 3GPP core, the 5G core, essentially. So the idea will be to initially to deploy MEC capabilities after the UPF. So, and from the point of view of how to handle the traffic, there could be different ways of doing that. One way could be, one straightforward way is just to make all the traffic pass through the MEC environment for whatever processing, for the applications and so on. But also there could be another, the purpose would be could be either task for processing the information and then sending the process information to the next hop, to the next edge environment, and so as we saw in the picture for the applications. But also other ways of handling could be to implement local breakouts for whatever application that could be local. So somehow splitting the traffic and doing some processing in the traffic for improving the performance and essentially to provide the user with the service that he or she is demanding. Next, please. So this is an example of that. So Make in this case would behave as an application function within the 5G core architecture. And according to certain characteristics that could be identified for the end user, for the user equipment, the terminal in 3GPP terminology, MEC could drive some actions in the traffic. So probably could divert part of the traffic local for implementing this local breakout, or leaving past the other traffic to the next data network exit. Let's say that would be the one that is on the right. So at the end, the point here is that through MEC, we will have the possibility of influencing the way in which the traffic is steered across the network. So yeah, there is room, though there could be room for optimizing things from the routing perspective in this respect. Then next, please. So I will comment a little bit now about another similar initiative which is being developed in ITUT. It's named Computing Network Convergence. And so how it's creating also a framework for control and management with the purpose of, of taking into account the awareness of compute environments at the time of allocating and orchestrating resources, including compute and networking. So next, please. So this project was, well, it's an ongoing project. So it's being developed in SG13, well, the study group 13 within ITUT. And the main purpose of the motivation of this project was more thinking on advanced services with the idea of the transition to beyond 5G and so on so far. So in this respect, they are considering cases of high mobility and time varying features, and with the idea of reconcile or take into account the resources that you could have in different edge environments that are spread across the network and manage in a common way with the networking resources in order to reach those different environments. Requirements that were considered at the time of moving forward this work was for sure the compute awareness. So understand what are the resources, the CPUs, the storage, and so on, but also what are the capabilities in the network side to reach those environments. Also considering fast routing and rerouting processes or situations in order to reach the different environments, different services and applications being run on these environments. Network protocol programmability and flexible addressing for dynamically deploy and instantiate services on top of these capabilities. Next, please. So CNC is considering three work items at this stage. One about the requirements, another one about QoS framework, and another one about management and orchestration. So the scenarios or the use cases that they are considering for illustrating or for developing the capabilities are low latency and high computing requirements, service consistency, and huge scientific data applications. These are the use cases where they are elaborated the needs that are expected to be documented in the ITUT recommendations later on. Next, please. So the work is yet on progress, is ongoing, so there is no too much, let's say, meat yet, at least available in the documents. So they have proposed, they are proposing this kind of architecture that somehow is inspired on 3GPP architecture, which is known as service-based architecture, where essentially the different components are connected together through a kind of service bus. And in this service bus, there are different capabilities for network control, for policy, and so. Yeah, so essentially this is the point where they are. So considering, as we mentioned before, extreme low latency, high computing, high mobility, dynamic services that could be deployed in different parts of the network, and energy savings also as well. So next, please. Well, this is the final one. This was just simply to summarize, I mean, two initiatives that are being developed in formal SDOs. Just to briefly comment, there are some other initiatives. For instance, in the Linux Foundation, there are some initiatives for these compute capabilities to be deployed across the network, and also in the GSMA. There is another one which is about name operator global platform, which at the end what proposes is to federate different environments across different providers, even connecting to hyperscalers like Amazon Web Services, Google Cloud, Microsoft Azure, and so on and so forth. So essentially to create a substrate of compute environments, and also, well, the objective of this, the purpose of this work that we are trying to move here would be to optimize the way of reaching all these compute capabilities spread across the network. And with that, I think that I'm done.
Um,
Thank you.
All right, thank you. Are there any clarifying questions?
So Eric, not Mark. So in this MEC and CNC work, are they viewing it purely as a routing function, or are they looking at like, how do we enable end-to-end security like TLS in this context, or is it purely routing?
Well, regarding routing, they are considering capabilities of influencing the steering of the traffic. So the possibility of inserting rules and so for this local breakout and so on and so forth. Regarding the point of view of security, I don't have an answer right now. I don't have an answer for you right now, so maybe I can comment offline in the mailing list.
Okay, thank you.
I would get that this is related to the applications that are running on top, but I will look for that and comment on the list.
Great. Thank you. Oh, there I have another question.
Oh, my name is Serge Karagianis. I need to put my name in the queue in a while. Just a question, Louis. So you mentioned that the work that's done in MEC and CNC might have an influence on what will be done in IETF, for example, for this work. What do you think? What kind of requests do you expect to bring to IETF from MEC and CNC?
Well, I think that the purpose will be to optimize the way in we could reach the applications and services that are running on the different compute environments. So to have ways of identifying, optimizing the proper edge in such a way that the delivery is the most efficient as possible. No? Behind efficiency, we could have better experience, higher QoS, higher throughput, and so on. So essentially to optimize the delivery of the services.
Okay, thank you.
A quick reminder, please state your name when you come to the mic. We'll have two more questions from John and AC.
Okay, I'm actually holding a place in line for Jim Utaro, who put a question in the chat. His question is, please provide an example of a huge scientific application.
Okay. It would be, for instance, the transfer of data sets that could be distributed across the network. So yeah, the interchange of the data sets between scientific research centers and so. So that could be a way. I mean, there would be ways of optimizing the transfer of this data that could have very high volumes, and yeah, optimizing that transfer essentially.
AC?
AC Linton, Cisco Systems. What is CNC? I found the multi-edge computing under Etsy. What is CNC? I looked it up and it seemed to be something about machine tooling. So I don't think that's the same one, same standard.
So I'm not sure I got the question properly.
What is the CNC standard? I've never heard of that. I couldn't find that one even
CNC
Google.
is compute and networking convergence.
What is it?
Compute and networking convergence.
Is that a division of Etsy as well? Is that a subgroup or?
So the CNC is done in or developed in ITUT, and MEC is developed in Etsy.
IT.
The problem will be clarified in the next slides. The difference between CNC and CN. Sorry for jumping. Yeah.
Yeah, they are different initiatives. Yeah, different architectures and so different initiatives.
Okay. Sorry, the queue is closed after Wim. Well, we have to move on.
Yeah, my name is Wim Hendricks from Nokia. My question is the following on, so today, if you look to the 3GPP architecture, you go to the UPF and then you have the MAC behind, right? So normally to select the proper edge location, already there is some 3GPP semantics happening to actually select the right UPF to get the best performance for that particular application. If you look at this work, what you're presenting here, what is this behind the UPF? You try to optimize where the resources are coming from that the application is going to provide to that edge location? Or are you trying to influence the 3GPP mechanism to make a better selection to select that UPF location? So that's my question regarding this bring new routing work to IETF, and which location or at which part of the architecture are you trying to do that additional, let's say, logic?
Yeah. Okay. Thank you, Wim. So what HCMEC is proposing are different use cases of integration. They are looking the way of how to integrate in the 3GPP. What we have seen here is just one example, one case, right? So in this case, the idea would be MEC identifies the specific user and then instruct the 3GPP to somehow implement, for instance, local breakout. And so there will be other ways of integrating, not only this one, but this, let's say, pure MEC architecture. So there could be influence on that in the routing for sure, but as I see, at least this would be, let's say, out of the scope of IETF. The IETF would enter in place once we have to do some routing or as consequence of this integration from HCMEC and 3GPP.
I just want to add one more
But
point
we can
here.
maybe discuss it offline. Yeah.
Yes,
We can
please.
discuss offline.
The MEC and CNC by ITOT is not the entire work done by IETF. So the later presenters will show what the work they expected to bring to IETF.
Yeah, this presentation is mainly to talk about the big environment, MEC and CNC, the work going on outside the IETF. And next, we will have the specific use cases. Move on to next one now.
Okay, can you hear me?
Go ahead.
Okay, this is Peng Liu from China Mobile, and I'd like to introduce same use case here. And please next. Okay, this slide can clarify some questions for the previous part of the CMC and CAN problem. So the CAN aims at computing and network resource optimization by steering traffic to appropriate computing resource, considering not only routing metric but also computing resource metric and service affiliation, which was showed in the chat slides. And we see it as the problem domain for IETF routing. And the similarity of CNC is that both of them consider computing and network resource joint optimization, but CNC focus on the vision scenarios, requirement architecture, and network function enhancement for future mobile core network and telecom fixed mobile satellite convergent network, but not for internet or routing area that IETF may concern. So I think this question can answer. This answer can answer the question before. Next slide, please. And before the real use case, I'd like to introduce some facts of the rapid development of integrated ICT infrastructure. Different from providing the network infrastructure only, the operators has been developing the CDN and edge sites these years based on their own sites, which to provide both network and information infrastructure. So at this stage, so many CDN nodes with servers installed, which can be appropriate to VCD and then edge computing infrastructure, while more diverse computing results need to be provided compared to the CDN node's original content cache results. Moreover, more edge computing nodes will be set up in an on-demand manner. Here's a typical analysis result, which is predict number shows that we may need to build so many edge nodes around content aggregation network, access aggregation network, and on-site. So not only for China Mobile, there are more and more service providers offering the integrated ICT infrastructure. So next slide, please. So why does the infrastructure develop so fast? It is because of user demand. Here are 2 points. First is that users want the best user experience, such as low latency and high reliability, fitting the emerging new service such as high definition video, AR and VR, and live broadcast, and so on. Another is that the stable service experience when moving to different areas. As we know, the mobile network developed better, providing more convenience for users to use lightweight clients to get more application service. However, only the new infrastructure themselves might not only enough to fully guarantee the quality of service. More work needs to be done. We summarize 3 points. First one is provide the functional equivalency by developing instance for the same service across edge site for better availability. And then keeps the load balance for both static and dynamic scenarios. By both up layer and network layer solutions. As we know, there are some load balance or traffic engineering for computing and network demand, but only for them, each of them. And the third one is steer traffic dynamically to the best service instance. It can be seen as traffic is delivered to optimal edge sites according to the more status, for example, edge computing, and the best should be defined for each service. Sometimes it might be the appropriate one, but not the real best one. Okay, next slide, please. So though we have the thoughts to meet the demand, but the fact is that edge computing has the advantage of closest, but in sometimes the closest is not the best, which is the point of the use case the problem. Some reason is that closest site may not have enough resource because the load may dynamically change. And another is that closest site may not have related resource. Heterogeneous hardware in different site sets. Okay, next, please. And here we use 3 slides to describe why the closest is not the best in some cases. This is a common way to develop the edge computing. There will be edge center for metro area which has high computing resource and will provide service to more UEs at the working time because more office building will be in the metro area. And there will also be some remote edge sites which has limited computing resource and provide the service to the UEs close to them. So in this case, the service request and the results are matched well. Some potential traffic steering may just need for special service request or some small scheduling demand. So please remember the location of the UEs that will change in next slide. So next, please. So we can see that in this slide, the UEs move from metro area to the remote site in the right side. It is because at the weekend or some the daily night, whatever, it's not the working time. More UE will move to the remote area that is close to their house for some weekend events. So there will be more service requests at remote, but with limited resource, computing resource, while the rich computing resource might not have been used with less UE in the metro area. So it needs to steer some traffic to metro center because only for 1 or 2 days can justify adding servers to the remote site. Okay, next, please. This shows there will also be some common variable of network and computing resource. For someone who is not moving but get a poor latency sometimes because of other UEs moving a large number of requests for temporary events such as vocal consent, shopping festival, and so on. And there will be also the normal change of network and computing resource status. So it is more optimal to steer traffic from some UEs to others DC. Next, please. Okay, from the above three slides, we get the first considerations. The high computing resource needed by UE at remote site for short period of time, which is not long enough to justify adding more computing resource at the remote site. So the traffic needs to be steered among different edge sites. Okay, next, please. So it is enough for just the one consideration and conclusion. More thought is that when steering traffic, what factors should be considered? Because some applications require both low latency and high computing resource usage or specific computing hardware capabilities, such as local GPU. Hence, joint optimization of network and computing resource may be needed to guarantee the QoE. Yeah, next, please. This is a typical application of AR and VR as an example. The upper bound latency for motion to photon includes frame rendering and requires less than 20 milliseconds to avoid motion sickness. Consisted of four parts. First is the sensor sampling delay, which can be seen as 1.5 milliseconds, and the second is display refresh delay, which can be seen as 7.9 milliseconds, and both of them too are in the client and not with control by the network or the cloud or server. And the frame rendering computing delay with GPU could be optimized to 5.5 milliseconds. So the network delay budget could be calculated as 5.1 millisecond. So we can get the first point is that budgets for computing delay and network delay are almost equivalent. And there's a picture in the right side shows that the client the client's request could go to the edge site 1, 2, or 3 to get service, and the corresponding network delay and computing delay shown here. So we can say that if we choose the edge site according to the computing load only, it will be edge site 1, and the total delay will be 22.4 milliseconds. And if we choose edge site according to network only, it will choose edge site 2, and the total delay will be 23.4 milliseconds. But if we consider both, it will choose edge site 3. The total delay will less than 20 milliseconds. Okay, the total delay includes the delay in the client, showed it is 9.4 milliseconds. So we can get the second point is that it can't meet the total delay requirement for or find the best choice according to either the network or computing resource status. So the final conclusion of these 2 points is that it is required to dynamically steer traffic to the appropriate edge to meet the end-to-end delay requirement, considering both the network and the computing resource status. And what's more, computing resource has a big difference in different edge sites, and the closest may be good for latency, but lacks GPU support and should therefore not be chosen, which gives more factors to consider in the computing resource. So next, please. And not only for the AR and the VR, more applications such as intelligent transport includes the connected car and video recognition at the intersection. We also have the requirement of joint optimization because both of them require low latency and high bandwidth and high computing resource. Moreover, due to the mobility, the load of network and edge sites may change dynamically and rapidly.
Hello? Are you, are you still there? We cannot hear you.
Hmm. Okay. In that case, should we move on to the next one?
Yeah, let's
Can
see. Maybe I can.
somebody else help finish the presentation? I think this is the last slide, right?
We have 3 more slides. Maybe I'll just show the slides and see people can read off the screen.
Introduce the slide.
Yeah.
Okay.
Oh,
Okay.
okay.
Basically, we will have more application. We need some new solution. Right. So as you can see from here, we have multiple edge sites, 1 and 2 and 3, right? But they have different requirements of the network, of the computing resources, right? So we need to
Sorry.
consider both. Okay, Polly is back. Do you want to take over the
Sorry.
debate?
Yeah.
Okay.
Yes. Sorry, I lost my
Continue.
network. Yes, I don't know where I broke. So this slide just show that there are more applications require the joint optimization of the computer and network results, and the mobility will bring a higher challenge of them. Uh, that will cause the network and edge side may change dynamically and rapidly. So next slide, please. Okay, so I can't see the screen.
Do you want me to
Okay,
move
yes,
to the
yes.
next one?
Yes. So, oh, no. Previous. Sorry, maybe network is good. No, not good. Yeah. Complete. No. Previous one.
I think we need slide 13.
The consideration before this slide. Yes. Here is the second consideration is that those apps require both low latency and high or specific computing resource have the almost equivalent budgets for computing delay and network delay. And the load of the network and the edge side may change dynamically and rapidly. So when steering traffic, the real-time network and the computing resource data should be considered at the same time in an effective way. Okay, next. Here we summarize 2 preliminary conclusions of it. First is traffic needs to be steered among different edge sites, and when steering traffic, the real-time network and the computing results data should be considered at the same time in an effective way. Okay, that's all. Thank you.
Thank
For
you.
the use case.
We have 2 minutes for clarifying questions. Zheng Yuan. Zheng Yuan, you are next in the queue.
Can you hear me? Yeah. I want to ask you a question. Why compute resource is different from any other resource?
Okay, good question. Computing resource includes the load, chip, category, and cache. It is different from the network resource, which can be measured by bandwidth and delay. So it is more complex to model, measure, and represent the computing resource data in a high variable way at this stage. So maybe the computing resource is a new work item, this information model. Yeah.
Meng Xiao.
Hi. Thank you, Peng. The use cases here are very meaningful, but I think some other applications like short videos, live streaming, may also benefit from the joint optimization of computing and network resource. I hope they could also be considered.
Okay, thank you. Here we just show some typical use case, and more applications will be considered in the future work. So we also welcome anyone who has an interest.
Wim Hendricks, Nokia. I have a question. So I understand the context, right? So when we say we want to steer the traffic to the proper edge, right? Do we say we have to select a UPF based on that application, or do we go beyond that UPF? So it's related to my first question that I asked during the session. And I also believe that probably you want to do the steering per user or per, let's say, the endpoint based on application, right? Is that, so it's not just an anchoring to the UPF, but you actually want to do it with application awareness that you say, okay, AR goes here, something else goes on this side because it has better resources. Is that my proper understanding of the context that you're trying to address here?
Okay, thank you. I think there may be two different areas to solve the problem. There's a way to choose edge sites based on the application or clients to select it, but we think for the critical use case like AR and VR, the application-based solution may be not as quick as the routing or layer 3 based solution, and I think those details could be discussed in the solutions part. Yeah.
Yeah. So the reason of my question is the following: to understand at what level we are trying to solve the problem, because I think there is potentially three options of doing this, and I'm not precluding it, but if it's really per application, you probably you need some application awareness, right? So you have to have a tie-in into that. The second way to solve it, and I believe 3GPP has a lot of mechanism to even do per UI and per application already today to say, okay, you can select based on this application UI a dedicated UPF, so that's already in place. So if that's true, then I think this problem will have to be solved or is being solved in 3GPP space and not in IETF. And then third is you could say, okay, you have to do something beyond the 3GPP level and actually do it in the routing system. But you have to, if the context is really 3GPP or 5G and stuff like that, we'll have to have that interworking with 3GPP somehow. So that's the reason I'm trying to understand a little bit the context of what and at what level and which parameters we want to use in order to do this.
Thank you. Greg, can we come back to it at an open discussion, please?
I think that my question is quite specific. I wanted to ask if computing resource is measurable and thus it's its own service level objective, or it's rather unmeasurable and then it's a service level expectation. Thank you.
Yes, as the previous question, computer resource measurement is not so being really either way directly. We may just consider two ways. One is the user index to represent its level for the load, or to bring more informations for small for more specific using. Yeah, and that will bring specific new work and may also can be discussed in the solution part. Yeah.
But if it's not measurable, then how it can affect site selection? So
yes, it could be measurable, I think, but it's just to choose measure it in different ways. Yeah.
There is a good saying: if you cannot measure, you cannot improve it. So it should be measurable, in my opinion. Thank you.
Let's come back to it during the open discussion. We're moving on to next presentation, gap analysis.
Yes, it's also me to introduce this part, and based on the use case discussed before, we can get the preliminary conclusion of joint optimization of network and computing resource. So here is the gap analysis requirements. Next, please. Okay, next. Here we list some existing solutions based on the assumption of supporting the network and computing joint optimization. Almost for two. One is a DNS use early binding to explicitly bind from the service identification to the network address and geographical location to pick the closest computing resource, and the health check to realize load balance and prevent single point failure. And the load balancer could be seen as the external components of network designed for computing demand to support the load balance. Okay, next, please. First is for the DNS. Yeah. We analyze it from three aspects. One is the early binding and the health check and the load balance over the DNS. For the early binding, it is for the clients resolve IP address first and then steer traffic. And it always use the DNS entry cached at client. The information are old and not be so real time. And often the resolver and the load balancer are separate entities, which incurs even more signaling overhead by needing to first resolve and then redirect to the load balance for final decision. So the resolution is layer 7 or application layer level decision making. For example, the database lookup, it is originally intended for the control, but not the data plan speed. In words, it may be a little slower to use it. And for the health check is on a infrequent base switch when failover. But the limited computing results on edge will change rapidly, while more frequent health check is prohibitive in cost. And the load balance over DNS usually focus on edge server load first, then utilizing lower latency routing to the selected server's IP address. It lacks a combined consideration for load and latencies for better end-to-end guarantee. And we'll also have the problem of how to obtain necessary metrics for decision. Okay, next, please. Second is for the load balancer. We show two common ways of the load balancer. One is a single load balancer in a single site for all server instance. It can be found in the edge site 2. There's a load balancer and worked among edge 1, 2, and 3. So the advantage is that it is easy to deploy, deployed, and but the cons includes that it has a single point of failure at the load balance, and the network path from the load balance to the server instance for other site might not be optimal. For example, as red and dotted path showed, there's an additional path from edge site 2 to edge site 1. Yeah. And another way is that each site has its own load balance. The problem is a deployment, but there's no load balance among multiple sites because it is only worked for itself. So it can't meet the use case or the requirement. Okay, next, please. Here's the summary of gap analysis. First one is the dynamicity of relations. The existing solution exhibits limitation in providing dynamic instance affinity. There are two aspects. First is dynamically, and then to keep the instance affinity to extent. We list the DNS as an example. It's not for designed for this level of dynamicity. It's minute level originally, and the client is to flushing the local DNS cache, and the frequent resolving may lead to overload of the DNS. And the efficiency problem is that the existing solution may introduce additional latencies and efficiencies in packet transmission, and the complexity and accuracy. The existing solution require careful planning for the placement of necessary control plan function in relation to the resulting data plan traffic, which is difficult and may lead to the inaccuracy of the scheduling. And next is metric expose and using. Existing solution lacks the necessary information to make the right decision on the selection of the suitable service instance due to the limited semantic or due to information not being exposed. And finally, the security, it can be seen as the existing solution may expose control as well as data plan to the possibility of DDoS attack on the resolution system as well as service instance. Okay, next, please. So here's the requirements. Next, please. We just consider from the use case and the gap analysis, here's the main goals to meet this use case. One is open choice, consider to access the location of multi-computing results, and dynamically considering to select the appropriate computing results dynamically, and then using the multi-metric to select the edge. So next, please. So here is the potential requirements. Maybe the format is wrong, but doesn't matter. First one, support multi-access to the available edge side dynamically based on anycast or other potential solutions. And second is support considering the using both network and computing metric. As discussed before, the computing semantic model information may be a potential work item for it, and the rate control signaling of metrics should be considered to not to bring so much pressure for the network. And the third one is support effective computing results representation and encapsulation by using the single index, for example, for the CPU threshold or multi-information for specific purpose. And the fourth one is support the interface between network and computing components, maybe by centralized or and decentralized advertising and signaling. And next is support the session continuity and service continuity to realize the functional equivalency in different areas. And last one may support the management of network and computing results. Okay, I think this is the last slide. So thank you for this part.
Okay, we have 2 minutes for quick clarifying questions. For open discussions, we have 30 minutes arranged at the end. How?
Hi. I am not sure if there are any other potential existing solutions need to be analyzed. So, hope to include more analysis such as SFC. I think this should be more persuasive for the web. Thanks.
Okay, thank you. We analyzed more than showed in the slides that is the case, in fact, and we will consider more analysis of other existing solutions. If needed, we will update in the draft. Thank you.
Qiang?
It should learn the network status to meet the use case demand, right?
Sorry, I didn't got your question. For what? Learn
Yeah,
the,
for the
yeah.
load balance, it should learn the network
Okay,
status
okay.
to the use case demand, right?
Okay, thank you. As I know at this stage, the load balance doesn't really know all the network status. It is possible with more details of the solution could be discussed in the following part. Thank you.
Okay, well, we'll move on to the next topic, two potential solutions, but then we'll come back to open discussion. Shraddha?
Hello, can you hear me? Hello?
Yes, we can hear you.
Yes, we can hear you.
Okay, so this presentation is about using load balancer based solution for the requirements discussed for computer web networks. Next slide, please. So just to reiterate the CAN problem statement, so it requires the traffic to be steered based on the computing resource or the load metric. Should also consider the network availability and the network metric. The third requirement is to have a service affinity. That is, same computing resource should always be used by certain clients. So this seems like a very familiar set of requirements. Uh, Next slide, please. So the definition of load balancer, right, as we see from Google search, it says it's a traffic cop sitting in front of your server. So basically, it takes the client requests and then distributes them to the available servers that are serving that particular application based on the workload on the servers. So, and it also keeps track of the health of the servers, and then the ones which are online, it makes sure it sends the requests to the ones which are online. Next slide, please. Yeah, so load balancers, they ensure high availability and reliability, right? So by sending requests to servers that are online and also ensuring the client requests are properly load balanced across these servers. So, and it also provides flexibility to add or remove servers as and when needed. Next slide, please. So the load balancers are also known to, support these session persistence, which means a certain client is a is a allocated a certain server to use that application, will continue to use that same server for that particular client. And this is called a session persistence in load balancer terminology. Another use case for this session persistence is also when there is some sort of client-based information caching that is used, and that also, using the same server, allows for using using that cache related to that client, which means better performance. Next slide, please. Yeah, so the modern load balancers also support service discovery, health checking, and intelligent load balancing algorithms. So service discovery is sort of figuring out where the services are, their location, and their names and addresses, and they're capable of finding out the load on them and then route the traffic to the ones which are less loaded. And the load balancing algorithms also keep track of, I mean, they're capable of, considering some network information, such as keeping traffic within zones and so on. So most of the information that we discuss in this slide deck is from the publicly available information, right? Like I am a routing person, like most of us in the room, and this information is mostly taken from Google search, where it landed me onto some official blogs on commercial load balancer products, which talk about what the load balancers can do today and where they, I mean, how they are, what is the future for these load balancers look like. Next slide, please. So the types of load balancers, layer 4 and layer 7 load balancers. So layer 4 load balancers look at mostly TCP and UDP headers, and they load balance based on that information, which is, so this L4 load balancers are highly scalable and better performance, but there may be some efficiency problems due to application layer invisibility. And L7 load balancers solve that problem. They look into the application layer and then they provide the load balancing. They're the most efficient, but they may be slower due to because they have to observe the packets up until the L7 application level information. So there is also a hybrid model that many solutions provide, wherein a mix of L4 and L7 load balancers. So there's a first level of L4 load balancer, and then which sort of load balances based on TCP UDP headers, and then there is L7 load balancer that will further load balance based on application layer information. So this is also sort of existing solution that has been that's available with the load balancers. Next slide, please. So we all know that network layer can provide paths with strict SLA guarantees, right? So it's responsible for delivering strict SLA. So if you request the network to provide paths from point A to point B, which are bandwidth guaranteed or latency bounded, for example, a path with within 5 millisecond delay, and then that should guarantee 1 gig bandwidth. That's kind of supported today by the network layer. It can either through distributed traffic engineering or centralized controller based traffic engineering, that the solutions are available in the network layer that can provide paths from one point to another point with strict SLA guarantees. And additional guarantees would also be served with network slicing solutions, such as reserved queuing and packet prioritization based on the packet types. Next slide, please. Yeah, so this slide is showing from point A to point B, paths satisfying strict SLAs, and network controller can it's capable of providing this strict guarantees paths from point A to point B. And then if a path is not available, for example, here from the top node to DC3, there is no there is no path that satisfies 5 millisecond delay and 1 gig bandwidth. So there is no path there. You can see that network controller ensures that paths are created only when these stricter SLAs are guaranteed, and paths are not available to a point if network cannot provide that path. Next slide, please. So knowing what the load balancer can do and what the network controllers can do, sort of analysis of whether the load balancer can be used for the requirements posed by CAN. So the load balancers and the servers are at the overlay. They're not really in the routing layer. They are in the application layer. And then they turn the server address to a individual non-anycast address, the individual site address. And that is, and when the load balancers do that, they use the information of the compute resource availability, the load on the compute resource. And when they do that, they also consider the network information, that whether the required SLA path, the required delay measurement, and the required bandwidth constraints are met, and a path to the particular site is available. They can take that input from the network controller, and a combination of load balancer and the network controller exchanging information can ensure that the right site is chosen uh, for choosing the location for serving the application. Next slide, please. So this is the load balancer architecture. This is where the future of the load balancing architecture is. The load balancers are deployed on the ingress. It's very close to the UPF. There are various options that are available for the load balancer. It could be virtualized, or it could be dedicated device, or it could be as part of software that resides along with the UPF. And then there's a global, so some sort of global input is also helpful in making the most appropriate decision while choosing the sites where the traffic is diverted. So there's a global load balance controller that sort of collects input from all the locations on the service instances and the load on those service instances, and provides input to the load balancers on that information. So it can also collect the network information from the network controller. So whether, for example, on demand, it can ask for information whether for this particular site there is a network path available that satisfies particular latency and bandwidth constraints, or other constraints that are required. And based on that input, the load balancers can make a decision to choose the right site where the traffic need to be steered. So most of this is all information on wireline networks, but it looks like most of the things are really common even for the wireless or the mobile use cases. The additional information and additional requirements would be to take care of UE movement in wireless environments from one location to another location, and using some sort of storing session information. Looks like load balancers would be able to support those use cases as well. Next slide, please. Yeah, so in summary, the CAN requirements involve selecting service instance based on current state of the service instance, and modern day load balancers, they perform sophisticated functions of choosing the right service instance. So they load balancers run in overlay, and they abstract the applications from the network. And so a combination of intelligent load balancers along with smart network layer. So they can probably able to solve the CAN requirements.
Okay, thank you.
Yeah, that concludes my talk.
Okay,
Any
we'll have
questions?
a quick clarifying questions. Dirk?
Hi, Dirk Trossen, Huawei. looking at the previous slide, I'm sorry, they were not numbered. I'm not entirely sure which slide I'm needing to go back to. You mentioned address rewriting. So it sounds like what you're proposing is a layer 3 load balancer, but isn't that conceptually the same as what the Dynecast draft calls a derouter? And the second question I have, if you have this slide on here, and I think Lars asked a similar question, I replied to his question in the chat, isn't there a lot to be talked about if you have load balancers now at every UPF, and I want to mix and match load balancers, I need to understand how the control traffic from the load balancer controller to the load balancers look like in order to have consistency of sessions. If I want to mix vendor A and vendor B on UPF 1 and UPF 3, I need to make sure that the entire signaling of the metrics that are being exchanged are somewhat understood and be treated the same way. Otherwise, I'm moving as a UE from UPF 1 to UPF 3, and suddenly my behavior changes because the load balancing decision is entirely different. So it's the question about where do you see, what's the difference really between the L3 load balancer and what I think the Dynecast architecture later in the next presentation calls a derouter, and how do you see the coordination between the controller and the load balancers being done?
Yeah, maybe you can listen to the next presentation about Dynecast and then come back to the open discussion.
Okay, thanks.
Yeah.
Just a couple of comments. One, ALT has been formed in 2008. A lot of the problems have been defined there and partially solved. Metric definitions. There are a lot of documents that are either RFCs or very close to become RFC. Please take a look at them. Number two, I think using and abusing 5G terminology is really dangerous thing to do here. It goes back actually to Wim questions. A lot of these issues have been solved in 5G packet core and control plane. It's not a routing problem. So we are trying to get a user to right location. UPF could be there, could be something, could be BNG. I think if we abstract terminology, the solution would become much more applicable. It's definitely not a 5G problem. So abusing terminology is a bad thing here. Number three would be looking around. Every CDN and hyperscaler, including my employer, we are deploying hundreds of edge locations every month. They're not connected by black magic. Let's take a look at what's been done. We don't want to take REAP version 2 and go to ADR and, offer them to do inter-domain routing with it. There's existing technology that really works. Thank you.
Thank you. Okay, well, very quick one, then we'll move on to the next one.
Dan Bogdanovic. So what hyperscalers can do with the existing technologies, their application and network requirements are aligning. But for the individual enterprises and the network providers, they they might not be aligning, and for that reason, some of the existing technology that that we are using today cannot answer some of the problems that the enterprises are asking.
Okay. Now we're moving on to the next presentation.
Hello?
Yes.
While we're queuing up the presentation, let me just remind everyone to state your name at the mic. I know that if you're using the, the mic line management app, it does pop your name up in the display, but that doesn't help with the recording. So please do remember to state your name. By the way, my name is
Okay,
John.
got it. Cool. Okay. Hello guys, my name is Zheng Li from Huawei. So the topic today is about diecast architecture. So what is diecast? Diecast is dynamic anycast, which has been proposed in the draft, the diecast architecture. So next, please. So diecast is a potential solution for CAN, right? So this is overview of the diecast service model. So first of all, you can see that we will have multiple service instance to be installed and running in multiple edge sites, right? And this kind of services will be presented by several anycast IP address, and this kind of IP anycast IP address will be distributed to the client by the DNS system, right? But the key problem is that the key question is that how the client can find the best server, the service instance among this kind of service instance running in different edge sites. That is the problem that we're trying to solve in CAN in diecast, right? So we define some elements, for example, the router, DMA, something like this. And I would introduce the detailed information in the preview and in the following slides. So maybe we can go to the next slide. Thank you. Next. Okay, we define some new terms. Service is really easy to understand. It's kind of functionality to provide some service, right? So the service instance is a running environment that makes the functionality of the service available, right? And one service can have multiple instances running in different edge sites at different network locations, right? We also define some new elements called the router, diecast router. It is a node supports diecast functionality, and we also defined the MA, diecast metric agent. It's an agent to collect information, to collect the how say the computing metric and send the metric among the MA and the routers. But it will not perform the forwarding decision, right? So in order to identify the service, we propose two terms right here. Diecast service identifier, uh, which is DC standing for, right? It is an anycast address identifying a service in the cast, and all service instances running the same service are identified by the same DC. And in order to identify the service instance, we propose a new term called diecast binding identifier, DBID. And it is a unicast and just so that the client can reach to the specific service instance by this address, right? So next slide, please. Okay, so in our design, the diecast architecture will have two modes. One is distributed and another one is centralized, right? So I will go into the details of the distributed mode today. And let's take a look at the distributed mode at the left side. In distributed mode, the diecast node will be aware of the status of computing resources. And this kind of metric of the computing resource will be distributed among the diecast capable nodes so that the optimal forwarding or routing decision can be made by the ingress derouter, right? In the centralized mode, we will have a computing resources management platform to collect all the status of the resources and send this kind of information to the network controller so that the network controller can make the optimal decision like the one in the distributed mode, right? So next. Okay, this is the distributed mode of the diecast. As you can see from this figure, we have multiple elements like derouters running in the network. This kind of derouter we provide the diecast functionality. And in order to collect the computing resources status and distribute them among the routers, we define the metric agent, right? DMA. So you can see that the DMA will collect the information and send to the router, and DMA can be logical function running on a specific router, right? So by this way, we can collect the information and distribute the information among the router. So the router can have this kind of uh, computing resource status. So combining the network metric and the computing resource metric, the ingress router can and do the best decision of forwarding. Yep. Next, please. Okay, so this is the format of the service metric information. In order to support that cost, we need to define a metric associated to the D seed and the D beat, right? And it should be calculated. I mean, the metric should be calculated and advertised. But regarding the metrics right here, it can be a single dimension value, for example, a number, right? It can be a multiple dimension value. It can be a tube of, with multiple numbers. It will be discussed in the future in the draft. And let's take a look at the example here. We will have anycast IPv6 address to be like DSeed, which identify a service, right? We will have a unicast IPv6 address 2001 column DB8 column 1 column 1, right? Identify a service instance. So with this kind of information, the ingress router can make the best forwarding decision. Next, please. Okay, this slide show how to distribute the metric among the routers. For example, we have D seed 1, D bit 21, and metric, for example, 1, right? This kind of information will be distributed. Yep. Next, please. Okay, if you take a look at this slide, you will see that it is really similar to the to it is really similar to the solution provided by the previous speech, right? The load balancer in the ingress router, right? Actually, they are really the same, the similar one, right? We provide the how say ingress anycast. You can call it ingress load balancer, maybe that's okay for the client, so that the client can get the best uh, service experience, right? So in this case, you see, as you can see right here, we have two DC right here. We have DC1 and DC2, which identified two services, right? But for each services, we have two respective uh, two service instance, 21, 31, 22, 32, right? And for and we have follow forwarding entry here for each how say diecast forwarding entry. We will have the metric information. So we have two types of metric here: network and service instance metric. So for the network metric, it would have it would be something like normal contrast or something delay, something like this, right? For the service instance, it can be a measurable index, or how say number, right? Relates to the load, the resource availability, something like this. So this is a really easy case for illustration, right? So in this case, a service demand with the destination address as DC2 will be sent from the client to the D router. And at the D router 1, right, if you look at the FAPE, you see that, okay, this is DC2. Let's see which service instance is the best. So you'll find the best service instance by look up the FAPE. You see that, okay, D beat D beat 2022, we provide the best for this request, right? So you will update the destination address of the packets from like DC2 to DB22, which is the unicast address, right? So by using this address, the packets can be forwarded from the drought 1 to the service instance dbit22, right? So which is very easy to be understood, right? Next. Okay, so this slide talks about some potential work. As you can see that it's really easy to understand. We need some flow affinity work on diecast to provide a better performance, right? But this topic is still open since the last side meeting. We have uh, collect multiple solutions for flow affinity, and one of them is this one. We provide a binding table in the ingress derouter. As you can see that we have a flow identifier. For example, it would be made by classic file to value the source IP, that's IP protocol, something like this, right? And it will be associated with a DID, a BID, for example, the BID22 right here, and we will have a timer as well. So by looking at the feed, the packets will be forwarding to the BID22 directly without mapping again. So this is some potential work in the future, and you are really welcome to provide any comments and question of this part. Yep. So next. Okay, perfect. So comments are welcome. Any question, comments?
Oh, okay, so we now move to open discussion phase. Linda will moderate for us.
Okay, so now is the open debate, and here we have Joe on the queue.
Okay, so I do have some comments for the open debate, but before I make them, I want to clarify the proposal I just heard. In the derouter, was the assumption that it encapsulates packets or not? Because earlier proposals did not talk about encapsulating. They were very clear that the address routing in the infrastructure had to be related to the selection. I looked at the draft. It is completely fuzzy on this now. I can't tell, therefore it's not a proposal. In terms of the slides, there is nothing that is clear. Is it or isn't it proposed to encapsulate?
Okay, uh, Joe. Uh, Actually, we're not proposing some specific encapsulation solution here. It can be an easy address rewriting, but if we have a tunnel from the deroute 1 to the bit ID 22, right? It can be
Okay,
encapsulation. Yes.
then you can't rewrite destination addresses. That is not permitted by the IP architecture. Sorry.
That's a good
And
comment. Yeah.
if we move to an overlay architecture and stop trying to inject this stuff into the underlay routing, we could then have a discussion about whether there was even a problem to be solved. We have multiple overlay techniques that already can tunnel where edge devices, which you want to call a derouter, but it's just the same as a lot of other edge application handling, can handle selecting a tunnel to deliver something. So I'm left really confused because your architecture either asks us to move stuff into routing for no good reason, or it isn't really doing anything new and we don't need a new working group to make use of tunnels in the routing space. Maybe we need a transporter application one, or maybe we need something that works on how applications tell the network edge what they want. That's a good
Mhm.
thing. That's a thing a lot of my colleagues want to work on. But
Yep.
having an edge that encapsulates a packet and delivers it over a tunnel to the right place, that we
Mhm.
don't even do working group for that.
Yeah, yeah,
Thank
yeah.
you.
Agree with that. Comment received. And I think you are proposing a good comment. Yep. Okay, next.
Okay, next
Hello,
one.
next.
Zongpen Du.
I'm Songpeng Du. I think this layer 3 load balance is one of the solutions for the load balance. Mapping any cast to a unicast address can provide a good way to select the best service instance. This mapping can be done in layer 3. In this situation, the whole network can work as a distributed load balancer. This layer 3 load balancer can both obtain the network information and the computing information, and it is closer to the user. So I think it's valuable to explore this layer 3 load balancer. Just a comment. Thanks.
Thank you.
Next one, Daniel Huang.
Juan from ZTE. My comments and questions is for Dynecast draft. I'm a little confused by the part of metrics of service instance in the slides. For me, when it comes to the time span from the beginning of the service in the service instance to the end of the service, it could run from minutes, seconds, and milliseconds. So when the time span is about milliseconds, so the matrix has to be updated in so high frequent to the remote derouter or whatever, where the forwarding decision has to be made. And actually, I don't think it is possible for the node for the router makes this decision because it's too fast. When you made so that's my comments and questions
Yep.
for this.
Yep. Thank you. Comment received. I think you are proposing some very important things of the updating. Yes, we will agree with that. So it would be update. It will not be updating per like millisecond, something like this. It would be a nightmare, right? So we need to set some bar or something like this, and it will be a completely an engineer task. So we believe that we will have a way out, right? We'll find a good way out. Yep.
Okay, next one, Jeff.
Jeff Kansura, the question is about metric normalization. So as Joel said, if you want to change destination, you need to impose additional header. You cannot change destination IP addresses, right? So we are going back to past computation, and even looking traditional PSEP and very limited number of inputs, computation is complex. At large scale, it takes minutes, if not hours. Here you're talking about unbounded number of inputs where it's not really comparable. Even. You cannot compare CPU load to GPU load to memory utilization to something else, right? So how are you going to compute a path for a particular destination with unbounded number of metrics that are not comparable? I really don't see it reading draft.
Yeah, thank you. So good question. Well, I think we can discuss more on the mailing list because it's a big question. Yep. How about that, Steph? Thank you.
Okay, Eric.
Eric Nordmark. So, I mean, it's good to have example solutions, but I think that there's still some big gaps in what the requirements are in this space. I think that people have talked about session continuity, and I think here was flow affinity, right? But the way, what that means from a networking perspective as opposed to an application perspective are miles apart, right? What we know from networking today is doing CDNs, where you tend to get things from the same place. And if you don't, you can restart whatever content you're downloading up to the application. But if we're doing some, computation, well, there could be, have this GPU that I find somewhere in my network near me. This GPU will compute on this stuff for an hour, right? And then I want to get the results. So is that what we mean by compute, or is it something that finishes in 10 milliseconds? Because the actual notion of continuity or affinity are completely different. And then it's not only over time, it's also over space because things move. So if I kick off this GPU computation when I'm sitting at the airport, can I go access it when I land back home? Right? Or is it actually tied to the particular operator running this network, having some service instance IDs or whatever a solution would have that is all local within scope? So it would be good to actually try to flush out, what do you guys actually think is compute? And for how long time does it run? And from where do I need to access it? Because otherwise, this is still just another CDN thing, right? Which, you know, we already know how to solve as an industry. So it would be good to clarify the requirements.
Yep. Good comment.
Hello. Hello, can you
Robin?
hear me?
Yes.
Can you hear me? Okay. In fact, Robin from Huawei, in fact, I do some clarification work in the chat box. First point that the people talk about the before work. I mentioned that the can work to some extent this is similar. The implicit thing behind the before and the can work is the operator can hold both the network status and the application load status, so they can achieve this the better traffic steering result. So I think this is the scope, because maybe in the other scenarios, the maybe these providers, application providers only know the application load status and cannot know the network status. But maybe in other scenarios, the network service provider only know the network status and cannot know the application status. So I mean that's the scope of the can work is that that's the scenario that the operator can hold both the network status and application status. This I want to clarify the first. The second one, I think now this is the use case and also this the problem statement has been clarified and presented. But we know that the solution is open. But for the load balancer, I'm not certain about it, because I'm not sure the load balancer is always co-located with the UPF or not. If co-located with this the UPF, maybe this belong to the 3GPP work and not the IETF work. This is the first one. I think this we must determine. The second one, I think that's for the load balancer want to learn the network status. I think maybe a little different, a little challenge, because that's in the network, there's the multiple, this the path. The path has a different status. I'm not sure how this network provide this status to the load balancer for the better traffic steering. So I think this is just my comments on the load balancer's work. Okay.
Okay, thank you. So regarding, yeah, I have some comments for the like regarding the diecast solution. I have to say that actually we only provide the solution for the uh, for one use case, that the operator have the network and computing resources together, so they can use that. We will not adjust the request to another edge sites which will be operated by another operators. That would be impossible. Yep.
Okay, thank you. So just want to emphasize that those are the questions we have in mind when we're doing the open discussion. The use cases are presented by Peng. So focus on those use cases, not random one. Okay, so Robin, do you have more things to say? Oh, you finished? Okay, next one, 月下富.
Yes. Thanks. I think that for the CAN, the key is the computing and the network joint optimization with the both computing and network information. And we finally hope to choose the optimal path and also the optimal service endpoint. So I think here the Dynecast provides a potential solution for CAN. Because I think that for the operators, we can hold both the network information and also the service load. And so then the network can learn the application load and to do more optimization. And also on the other hand, here some people propose the service continuity problem. In fact, I have noticed that in Dynecast solution, here is the flow affinity related issues. From my understanding, I think that Dynecast will select the service node when the session starts, and this service nodes will want to change until the session ends. So I think from this point of view, we can solve the service continuity problem from a certain extent. And so in conclusion, I think that as for the Dynecast solution, we can go it further and to explore more. Yes, thanks.
Thank you. Next one, Ketan.
Yeah, Ketan Talaulikar here. And I'm kind of maybe adding on to Jeff's comments here. So the key takeaway for me here was this notion of network metrics, and there was congestion, there was computing load, and probably other more stuff. I think that part is somewhat interesting, but I did not see it being clearly specified as to what it is. What kind of
Mhm.
metrics are there? How are they injected? How are they measured? How would they be used in routing protocols, let's say? I
Good.
think that part is probably within the routing area and perhaps something to look at. So
Yes,
if
exactly.
the proponents have some very specific fleshed out or ideas, then perhaps I would say routing area might be a good routing area working group. Routing working group would be a good one to discuss that
Yes,
further.
agree.
For the rest, yeah, for the rest, I'm not very sure if this is a routing problem or
Mhm.
not. Yeah.
Thank
Thank
you,
you.
Captain. So one comment right here, like yeah, you are right. The metric hasn't been described specifically right now, and this is a big work that we should focus on the future. So I think that this kind of work would belong to the RTC area for sure. And yes, I agree with you. Yeah.
Okay, next one, Dean.
Yes, hi, Dan Bogdanovich. So throughout this ITF, we are seeing some common themes that people are bringing uh, to the groups and trying to solve. And it's pointing out that we have some underlying fundamental problems that we have to look into it, and we have to think and start having an open discussion about those. So yesterday there was a problem with how to route in the satellites. We are hearing that, hey, we would like to add more than just where to route, that we want to decide also why are we routing and what are we routing. And yesterday there was a good presentation in the routing working group that addresses this uh, problems that we are hearing and the use cases that we are seeing in different working groups and in different drafts uh, that addresses fundamentally that. So we also have an issue that there's more and more mobility being brought into the mobility problems are being brought, and as the 3GPP somewhat owns the mobility architecture, they are trying to push the 3GPP restrictions that are very much telco orientated and that are uh, done with the telco architecture in mind and push it out into the IP world. That's another thing that we have to look and see how that mobility problem can be solved, and not trying to continue with some patch solutions, I think it's about time for us as a community to look into the fundamental problem and trying to see what can be done there. There are some bits and pieces of this work, but we need a place. And this is my ask to the ISG, first to the routing area directors, and then to the ISG, a place where we can have that discussion, where we can have that conversation about the problems that we, about the fundamental problems that we are seeing and that we are trying to solve.
I agree. I agree.
Thank
So
you.
thank you. Thank you. Um, so we don't have much time left. We only have like 5 minutes left, 10 minutes left. So let's go quickly, focus on this work. Thank you, Dan, for bring up other bigger problem we need to address, or IESG need to address. So next one, Greg.
Mr. Erickson. So it seems to me that this is we're discussing is a new or presented as a new performance metric. So I think that it might be something that IETF can work on if it's different from, for example, a latency introduced by computing. Uh, I don't know if we are in a position to do computing capacity measurements or how to guarantee that using IETF work. But I'm not sure that if this is about performance metric, that the routing area is the right place. I would point to IP performance measurement working group that works on various performance metrics and the measurement methods, uh, active and hybrid as well. So if there is anything to do with a new performance metric that expresses or reflects computing resource, then it might be IPPM working group. Thank you.
Thank you. AC?
AC limit system systems. I just want, I mean, I agree totally with both what Joel and Jeff said, and my comments would be the same. The um, the Dynacast architecture is as such, it's very wishy-washy. It just kind of throws together, oh yeah, we have these new metrics, and I think I'm worried people are going to start working on all these details. In the end, there's only a single routing decision, and it's got to, you know, injecting all, you know, 12 a dozen different metrics doesn't really do you any good, because you got to all everybody's got to normalize them and figure them out, and it's with the load balancer, you already have a solution in an architecture. I think mixing these things up is misguided, and I'm worried people are going to just start working on details without agreeing on without having a good starting point. You look at it also with this Anycast address. If you're not tone, everybody's got to be using the same algorithm and the same metrics. Otherwise, you're going to have loops. I mean, that's a well-known fact in routing. So let's not have. I don't want to see a bunch of drafts with the details of this before we agree on our architecture. Thanks.
Thank you. That's a good point. Yijo?
Yeah, actually, I'd like to provide some of the preliminary hints on how the metric could be defined, because we have done some preliminary implementations on this area. So uh, the whole work is trying to use the joint optimization for the computing metrics and also the network metrics. So basically, we can have the normalized metrics for the computing resources and the normalized metrics for the networking resources. So we are talking about the normalize the computing resources here. The simplest way is could just be to use the number of sessions over the total number of sessions can be supported, for example, per CPU core. Remember that we are using the IP Anycast to denote a service. So basically, when the IT system trying to deploy the services, it knows that this one I use maybe 2 CPU cores to for it. So roughly there is a normalized matrix that say the total capacity of the number of, in terms of number of sessions can be supported. So that's how the Anycast IP addresses or the destination IP addresses coupled with the normalized computing metrics. Of course, the computing resources and the network resources should be calculated in conjunction ultimately. But here it's just a simple example how it could be done. So I just want to provide this kind of information.
Thank you. Thank you. We're running short on time. Tianjin, can you just quickly state your questions or maybe have longer discussion on the mailing list?
Okay, sure. I have just some very simple comments regarding the 5GS as the example here or use case. I think it's very significant. Since even right now in the 5GS system, it start to introduce some projects, the seed or wait to even expose the UPF information throughout the external world, and then like for like trusted AF those things. So that will be some paths to introduce to bring the nanometric or computing metric. Those are the concepts to integrate with the networking part and the 5G part. So I think this work is important. So well, at least for the use case mentioned in the presentation. So thank you.
Thank you. So thank everybody for the presenters and also people asking questions. Last but not least, let's our AD John say a few words about his feeling about this session.
Okay, so thank you, Linda. Thanks everybody for your participation. I think that this was a really good and really well-engaged conversation. So when the proponents proposed the BOF, they said their goal was to increase awareness and increase participation. And I think that from that perspective, this BOF has already been a success. I believe the proponents have gotten a ton of valuable input and a lot of homework to take home and work on, and it should keep them busy for some weeks or months to come. It would be really nice to not see the energy that we've built up today dissipate. I'd like to remind everybody there's a mailing list to continue the conversation on, and I hope you will use it, and in particular take your comments there that you've pasted in the chat room, which I've only vaguely kept up with, because as usual there's too much information streaming past between chat and what's being said at the mic and so on to follow it all. So please do follow up on the mailing list with that. With regard to sort of the questions that we've got here on the slide, I don't think I saw any disagreement that the use cases are important. I heard a lot of reference to existing solutions. I did not hear a consensus that you simply need to apply existing technology and we're done. Although I did hear a great deal of, have you looked at X enough? For example, Jeff mentioned Alto, and there were other things. I think that there's certainly a question about whether existing technologies have already been paid enough attention to. Regarding whether the proposed architecture would be harmful in any way, I heard, especially from kind of traditional routing area people, many people saying, you know, wherever this work is done, do not put it in the underlay. There was a loud plurality of opinion in that direction. And regarding where the work should continue, there doesn't seem to be a consensus. There does seem to be a consensus. There are various pieces, and that at most only some of them are part of routing. I think that we're going to have to continue to chase that question. One other interesting thing that, interesting to me anyway, was the sort of in the discussion of load balancers versus, you know, something else, was the point that Dirk brought up about, well, the derouter in Dynecast is really, you can think of it in terms of it being a load balancer. And there were some other comments in the chat about, well, gosh, is really what we're looking for is standardization of load balancers, because right now they're, you know, all proprietary secret sauce. So, you know, we're at the top of the hour, so I don't want to make us run over. But, you know, just to reiterate, I think that, you know, we've had a good BOF today. We've surfaced a lot of valuable points. I think that this discussion can and will continue, and it's there is not, to me, any clear next venue for the work to land in other than on the mailing list. But you know, you have a lot of people's attention. Let's keep it. Thank you, and if the chairs would like to say anything to wrap up, please go ahead.
Thank you, everybody. Just make sure, go back to the notes. If you ask questions, make sure your questions are captured and your names are captured correctly. Thank you.
Thank you,
everyone.
thank you guys.
Thank you,
So
Joe.
please
Thanks.
don't forget that mailing list. Tell us anything if you want.
That's right. Mailing list is Dynecast. Dynecast.
Yeah, Dynecast.
Thank you. Okay, bye-bye.
Right, thanks.
Hey, Jeff. So do you get the blue sheet? Like, do you know how to get the blue sheet? Is it automatically captured?
Blue sheet is automatic.
Okay. I find the chat window has many interesting questions, interesting suggestions. Okay. Thank you so much. Okay, take care.